Ifani is a data scientist and research software engineer in our data analytics team here at LIDA. He supports a wide range of data science projects which use sensitive data, primarily providing data engineering expertise across secure research environments such as LASER and the UK Biobank research analysis platform. So I will hand over to Ifani for his presentation, and we hope you enjoy.
Hello, everyone. Thank you very much, Anna, for that warm introduction about LIDA and what we do. So today, we're going to talk about data engineering across TREs or secure analytics platform. Again, I'm an RSC research software engineer. LIDA, data analytics. So my presentation today is going to be in 2 parts. So part 1 of the presentation will introduce, briefly about what a TRE is and why we need a TRE, and also types of TRE. And then part 2 is, data engineering a TRE, and we have one example that we want to explore. So I understand that, some people joining this call already, or some people that watch the video would already have had an understanding of what a TRE is. But I also understand that some may not have understood what a TRE is, so that's why we are introducing a TRE. So, TRE in its, broader sense is a combination of computing technology, data management process, and information governance that is required to provide and safeguard sensitive data for research purposes. And the keywords really is what I've underlined there. So because they all come together to work to be what a TRE is. It's not just one of it, but a combination of all these things. And the TREs primarily exist because many high-value data sets in health, in population sciences, in customer interactions, in banking sectors, etc. So these data sets contain personal or identifiable information, and this data set is needed for research purposes. So for research to happen, so we need to have a place where we could legally and ethically hold the data for research purposes, and that's where TRE comes in. And within the TRE, usually data cannot be shared freely or copied, across platforms or downloaded into local machines. But researchers are usually granted access into a TRE and where they come there to do their work, and the output of the research is examined, data flow is controlled, and the output is examined before the researchers are, the output could be removed from the TRE, and it's usually aggregated data sets or summary statistics as the legal basis agrees. So just a key attribute of a TRE is, secure data access, usually could be airlock system, and data control is, data flow is controlled, and usually TREs have security standards. So in my estimation, I've put 2 broad categories of TRE, and one is data-centric TRE, and the second bit is platform-centric TRE. And the data-centric TRE is a TRE that has been built around specific data sets. So this is a situation where an organization have collected data set or own a data set and have built a TRE around the data set to enable researchers to do their work, to enable researchers to securely do their work within that space. An example of those type of TRE is the UK Biobank research analysis platform. Another example is NHS secure data environment, and there's so many other type of these data-centric TRE. The other type of TRE really is the platform-centric TRE or data-agnostic TRE, if you like, which usually does not own any data set, but it accesses data sets from multiple sources. And research they enable research to happen because of that's the collection of data sets, and then gives researchers a secure access to a particular network segregated space for their work to happen. An example of this is LIDA, which is the University of Leeds TRE, which we run and manage. And there are other types of academic TREs as well that falls within this category. So as an attribute of a TRE, governance is a key attribute, because without governance, TRE is not really a TRE. So governance is assessed with legal basis, ethical approval, and permission. Training is offered to researchers and members that want to access the TRE, and they need to authenticate to have access. Secondly, they also tools that are assessed within the TRE, because they vary from type to type and depending on the research requirements. So the tools that are available could also widely vary, which include Python, R, Stata, and SQL, and all those other tools depending on the need of the researcher. So data engineering within this TRE really focuses on how efficiency, how we can, data scientists, data engineers can work with this flow within the TRE and provide researchers research-ready data to progress with their work. So this really leads me well into part 2 of the presentation. That's look at data engineering in practice, and I'll give specific example at the end on HLA on the UK Biobank wrap, which is another type of TRE. So, but before we go, start, into becoming a little bit into that domain of HLA and what that means, etc., I want to first of all, talk about data engineering and also introduce the platform that the work was done. So, data engineering in itself, I've also, based on the work I've done, experience, and other external resources, try to put data engineering as something that sits between 3 key points. So we have the tools, we have the platforms, and the expertise. And the data engineering kind of sits within those 3 key points. And this is very, little summary of this. Other experts could define it in a different way, but this is how I've defined data engineering. So tools that data engineers need to master or have an understand to use could range from Python, PySpark, especially if they're working with large-scale big data sets that are multidimensional, and good understanding of R. SQL could be very good advantage. BigQuery is another tool that need to be understood. In terms of the platform, nowadays we have quite a wide range of cloud-based platform where research, data can be held and data engineering could be done. There are other non-cloud-based platforms, but for this presentation, I've put a number of cloud-based platforms. You can see Azure platform, LIDA, which is in University of Leeds TRE, is built and maintained in Azure Cloud, Microsoft Azure Cloud platform. We also have the AWS system, which the UK Biobank is also built on, and the team that, or the company that developed that is DNA Networks. And again, we have the GCP, Databricks, and other types of platforms. So having our understanding of this platform and how you can work across them is really important when you are working on data engineering. Again, this could also be done on your local system if the data is held there, and if it's not sensitive data that is held within your local machine. Again, I've also tried to map the expertise that is needed in data engineering, because I also understand that there could be a wide range of people in this call or watching this video that may want to understand what you need to understand data engineering or come into data engineering. So again, this is also an a subjective view, based on my experience working in data engineering. So I say they definitely need an understanding of programming and software engineering skill, at least in one of those languages listed above. And you also need to understand database and big data, because to engineer data, you need the data itself. And usually big data need to be engineered. And data wrangling, you also need to have an understanding of how to wrangle data, and that is making data to be in format that is user-friendly and research-ready kind of data. Data usually come in a very messy, segmented and format where data engineer kind of bring them together and build them in a format that is used for research. You may not necessarily need to have a high statistics skill as a data engineer. That is a plus if you do. Data engineering visualization skill is also not at the top of the list, even though if you have it, it is cool. And domain expertise or business insight. You may not necessarily have a domain expert to be able to work in a particular data. And usually as a data engineer, you work in collaboration with other people, other expertise to work on a project. So usually you can work with statisticians, you can work with clinicians and other people that have certain domain experts. In my case, I worked with clinicians and statisticians on the project. And so next, I will quickly introduce the UK Biobank platform and the data that we used to do some data engineering. So the UK Biobank platform, has about UK Biobank itself recruited about 500,000, slightly above 500,000 participants between the age of 40 to 69 years of age, between 2006 and 2010, and have collected over these years, wide-ranging data from these participants. It's a longitudinal study, has followed up these participants for that long time. So it's quite a very rich data set. And this data can include imaging data and genetic data, lifestyle data, questionnaire data, environmental data, any kind of data that is useful for research is collected. And then I've highlighted healthcare record because it's also one of the data that is linked to the UK Biobank data. So all the participants' healthcare record that is available in the GP, in secondary care, their medicine, and other things is linked. So this data set is quite massive. It's really, really large. We are talking about petabyte size of data. So you really need data engineering to be able to navigate through the system and make the data ready for research. So just a quick glance on the data assets that we used within this project. So obviously we use the primary care data, which is one of the healthcare record I mentioned. And these are like 118 million events. It's also large scale data that needs to be, and we need this data to talk to other data and link them accurately and create a cohort. So, but what is interesting in this data is the clinical codes, and that is where, as a data engineer, I need to work collaboratively with people that have domain expertise to understand clinical code and code them appropriately, correctly, so that the data can be correctly engineered. So we also have the prescription data in the primary care as well. And this prescription data, again, has all these attributes listed there, including the medication code and the quantity. So, and that is the medication code as well. As someone who is not a clinician, may not really understand this medication code, and that's why I need to work with experts to, highlight these clinical codes, medication codes. There are thousands and thousands of them to go through and pick out the one that are relevant and include them in the study, in the script. So there are usually 3 types of clinical code, but I won't really go deep into that now. Another is the health data as well, which is hospital episode statistics data. Again, the key data point of interest in health data is the ICD codes, which is also another clinical coding data that we work with experts to understand what that means and then do that in the scripts in the data engineering pipeline. Again, these are the number of the cohort is listed in the N events in the screen. So for specifically this presentation, I will be talking about a HLA data set, which is human leukocyte antigens, which is a kind of genetic data that is really interesting because for each participant in these 500,000 UK Biobank patients, they have mapped their genetic HLA based on 371 columns. So it is quite vast and massive that it can easily get lost, trying to understand what that is, trying to accurately map them. And, because they are binary matrix zeros and ones, each is representing the presence or absence of a genetic allele for the HLA. So we studied the disease of interest, and the HLA enabled us to confirm if the cohort we've created is indeed accurate or not, because the people's genetic marker could indicate their likelihood of having some certain health outcomes. And the HLA was really, good, even though it's wide, to map out these health outcomes. So again, we talk a little bit more HLA. So again, because of the array of HLA, and so we need to understand and prepare HLA data on RAP, UK Biobank RAP. So the HLA data is complex, just a binary number, zeros and one, that, as, a layman in this field, we may not really understand what this means. But we need to iteratively work collaboratively with researchers who understand that means and pick out the bits and pieces that are relevant to the study and map them and accurately for the study. And also because it's wide, is a wide array data, so we need to also make effective combination of the genetic or allele combinations and prepare the data to validate the cohort that we created for the next step in the studies that followed. And so to derive HLA combination and produce analysis-ready data, that's the key objective of what we try to do. So we did a lot of future engineering of the HLA combinations. So again, because of the array of the data we used and the size of data, we use Spark, PySpark, which is a tool for working with large-scale data of this type, so that you can, query and structure them, prepare them for the analysis. So again, we put this data ready. We use the PySpark tool to get the data ready, and because the data research is happening within a TRE, it needs to be done securely and not outside the research environment. So again, so there are 4 key data sets which I mentioned previously that we used. One is the HLA data, and the other one is the participant data, which shows the age and other characteristics of the participants. And then we have the multi-morbidity data that show the conditions that each participant may have based on their clinical record. And we also have the medication prescription data based on the medication that participants may be taking over a period of time. So, and we needed to make these data talk to each other and put them in a correct format because they are, vast and, numerous of them. So the pipeline really is, to produce a Spark data engineering layer. So we had, injected raw data from different sources, even though they're in one system in the UKB RAP, but they are still in different sources and segregated from each other. So we needed to inject this raw data from these sources. We cleaned and joined them. We made feature engineering when we provided a combination rule, and we use it to define the cohort for further analysis. So I will just give you a strategy of what we did, an example of the code without going into a lot of details for some reasons. One is that the study is still ongoing, study have not been completed, so we cannot necessarily share the output at the minute. And secondly, due to some governance issues surrounding UK Biobank wrap, we cannot necessarily access it at the moment because of some governance issue. Remember, in the definition of TRE, governance really plays a role. So when governance is removed, TRE is no longer TRE. So governance is preventing some access at the minute from UK Biobank platform. So here is the mapping strategy we used to create the cohort. So we had about 16 cohorts for this study, but we kind of put them in just a little chunk of 8 for this presentation. And they are this is quite a very brief summary because there are a lot of data everywhere. So, but this is kind of a strategy that we developed. So we got the cohorts based on their clinical record, based on the genetic, based on the codes and the condition that they had on the clinical record. And we found the number of times they were having blood tests. The blood test data is quite also another hundreds of millions of rows. So we needed to get these participants in each group that has blood test frequency once in 6 months and 3 times in 1 year to create the cohort of interest. And we also went to the medication they are taking to go through different data sets and find for each of the participants, find the medications and categorize these medications. In this case, we were interested in different types of steroids. So there were hundreds and hundreds categories of steroids, but we've kind of summarized them into 8 usable formats for further analysis. And then while we are doing that, we also link them with use the HLA data that I talked previously, which is the genetic data to confirm the creation of the cohorts. So at the bottom of the screen, what you can see is an example of the research-ready data that we provide at the end for researchers to do their work with that. So I wouldn't dwell so much on this, so I'll give you time for questions. So this is an example of the script that we used. This is some Python scripts, and the one on your right is sub-cohort creation, one of the cohorts that we created. But I will just quickly jump into an example of the result and how HLA help us to define a cohort. One is the image on your left and then the image on your right. So we have a control group and 5 groups that we created. So each of the HLA shows the genetic response, the genetic predisposition or prevalence within each group. So the control is the baseline, and each of the group, I'm talking about the image on the left at the minute. So each of the HLA shows, okay, group 1 have this amount of type of HLA, has this amount of type of HLA, and so compared with control. So, but it could be difficult to really understand what's going on there. And we kind of try to normalize it in the slide in the image on the right. And normalizing it is kind of using the control as baseline. You can notice that they are all under 1. All the controls are under 1 in the right slide. And the controls, the different groups shows how, compared with the control, what the prevalence of HLA in this other group. So what this helped us to do is that we found out that group 1 really, really confirmed with the researchers that the cohort we created was really accurate in group 1 and group 2, because HLA1 was really, really prevalent there, and that is what was expected, right? For them. So it confirmed that the data is ready for research, and they're able to take it further for their work. So I would end here and just give a quick summary of, hopefully you understood what a TRE is and the type of TRE. You have understanding of what data engineering is and platform and tools, etc. So I would end here and give opportunity for questions. Thank you.
Thanks, Fanny. Excellent presentation, and we'll go through now for any questions. We did have one come through during the registration process from Joy, saying, I want to learn data engineering, what should I start with? Joy's currently a project officer. If you've got any advice, Ifeanyi.
Yeah, so that's really a good question, Joy. It's quite really interesting that you're interested in data engineering, and hopefully this presentation has helped a little bit in shedding light into what data engineering is. To learn more about data engineering, that it really depends on the level you have at the moment. What's your level of expertise? Obviously, you're a project coordinator, I understand. So if you have some technical background already, you could, start working on some projects, looking for opportunities within data science and data engineering that you could do. Or you could, and while looking for these opportunities, you could, begin to, in your free time, play around with some resources, online resources on data engineering, and know how you can wrangle data and make them ready for research. Again, University of Leeds also offers a training program, for people who want to have, if is your interest to explore that opportunity, you could also reach out to University of Leeds to see what programs they could offer you, especially within LIDA. There's some programs that are there that you could benefit from, and some training opportunities in LIDA website where they train people on data wrangling or data engineering, or using some tools like R and other programming tools. So I will take a look at LIDA website that is listed on the slide to get further information on that, and use a lot of online resources as well.